Hey everyone, guess we are just waiting for Peter to inaugurate the meeting that we always does. So let's just give him a couple of minutes.
Sure. Hi.
MK.
Hi everyone.
Hey Peter.
Hello.
Hi Jennifer.
Hi there.
Give me 1 second.
Oh, you're on mute.
Yeah, I'm ready. Can you see the screen share?
Yes.
Okay. Welcome everyone to the Cacti Maintainers meeting. Please abide by the antitrust policy notice that's on the screen, and also by the Hyperledger Code of Conduct, which you can link to on the agenda documents. And this is unfortunately last week's or the week before's agenda document, because I didn't have another one, but it doesn't matter. We can just get going with the discussion. So, who has what?
Well, I can briefly talk about the COPM primitive REST API definition,
Okay, please go ahead.
or rather the Open API spec would be more accurate. Okay, I'm going to share my screen. Okay, can everybody see?
Yes.
Okay, so 3 endpoints defined. The in the schemas, most of them will have a link to where they come from. I mostly use the RFCs with the idea that where the code was not quite the same, we can match the code up to the RFC. So the pledge asset has a source, a destination, and an asset and expiry seconds. And then again, if you're not familiar, Rama, with how the OpenAPI viewers work, you can flip to see the schemas. So the claim asset, I went a little bit different from the RFCs in that the claim asset could just reference a pledge ID and then use the pledge ID to work out where the asset is coming from and where it's going to. And the view for proof state, the schema is the state proof, and we'll just go through it down here. So the state proof is a view address and a verification policy. And then the view address has the parameters that you've specified, Rema. And the verification policy is a security domain and some rules, with the rules being a policy type and a policy criteria. And the criteria is operators and values. So there are some examples. So one thing that this is just the working definition. We've got some things that can obviously be improved on. For instance, proof state doesn't return anything right now. It just returns a 200 OK. So, but I was thinking probably you can just return a Boolean. So this definition will evolve as I get further into it.
What exactly? So I know we were discussing the list maybe a week or two ago. What will proof state do exactly? It's going to return a view and a proof?
Yeah, so I thought that proof state could just return a Boolean. So I thought the intention was to see if something was true or not. And then if it is true, it can just return true. But if we want to return a view, we could do that as well.
Oh, did you mean for proof state to be the validation of a proof?
Yes.
Okay.
Does that make sense? So instead of having what were the primitives? Let me just pull them up.
I would say it. Yeah. Proof state has different connotations than what I guess the functions are doing there. So here's the if you have this end-to-end protocol, you're going to be exercising this function at the receiving end, right? So the end that receives the view and the proof. So it's trying to validate whether or not the view is authentic and correct. So saying prove might sound slightly misleading. So I would say maybe validate state or validate state proof or validate proof validate state proof something like that. I mean, I think I would like to have the word validate there somewhere rather than use prove as the verb, because it's not the job of the validator to be proving anything. So it's the job of the whoever's sending to be proving that whatever they are sending is correct, and that's why they're attaching a proof. So at least that's how I see the grammar here.
Okay, so it's not the job of the API to say yes, that's true, or no, that's not true. So it's the job of the API to return the data so that the application can do that?
No, it is the job of the API to say yeah, it is true or not, but it's not the function's performing is not, it's not proving anything, it is validating proof. So I think the word validate and prove are mean something different, right? So that's why I prefer validate or verify, something like that.
Okay. Okay, so I will just leave this. You guys have the link in the Discord chat. You can review it at your leisure and give feedback.
Sure. I did take a look at it earlier today. Just go back a little up, scroll a little up. We were also discussing the notion of pledging, right? I think at some point you were asking about the difference between pledge and lock. So I was thinking, so I mean, this is an artifact of how we implemented it, because initially, as you know, we have the three protocols, right? We have the data sharing, from where the vocabulary of views and proofs comes, and then we have a asset exchange, from where we had locks and claims, and then we had asset transfer, where we use pledge and claims. The only reason for using pledge was that was we wanted to distinguish it from lock, because the semantics of that operation differed from how we were implementing locks. But I think it would be just useful to have one single word for it. I think you were also suggesting this, right?
Yes.
And if we are using one word, I would prefer we use the word lock, because I think that is more generic than pledge, and maybe more less prone to getting misunderstood. So the word
Okay.
pledge has, I mean, if you talk to finance people, they might think uh, it means something when it doesn't. So I think the word lock, uh, it has a particular technical connotation, which means that you're trying to freeze an asset, for what purpose and for who, all that is up in the air, and that we can uh, attach the right spec to the lock, then we know what to do with it, or how to interpret that lock. Uh, so I think it would be good to use that word, and a lock with suitable specification can be used in the same way that a pledge is currently being used in the Weaver models. So I
Hmm.
would prefer the word lock.
The base code though for the pledge in Weaver,
Yeah,
the function in the utils, it's just it doesn't actually do anything to an asset. It just marks it. It's like maintains a data
correct,
structure.
correct. It doesn't, because the in both, if you look at the samples we have for both the asset exchange examples and for asset transfer. And there are samples inside if you go inside samples, fabric, you'll see there's a chain code called simple asset and
Mhm.
some variations of that. And then there's a couple of chain codes called simple asset transfer. So the thing is that these assets, the chain codes are designed in such a way, and the equivalents of chain code in other systems, like in Corda, you'll have contracts to do the same thing. In Ethereum, you'll have contracts as well. Uh, the how exactly the assets are managed, and what you exactly do in order to freeze those assets, and move it from transfer from one party to another, is completely under the control of the contracts. And in Fabric's case, with that particular chain code, so it, it's hard to provide a generic function that will do something without either providing the hooks for the application uh, to actually do the locking, uh, uh, and tell the caller that, yeah, I've logged the asset as you've instructed me to. So that's why we can't have uh, something that does, like, something outside of the application chain code that does the lock, and not have the application do anything, because the application is the only one which knows how to manage their asset. From the
Mhm.
perspective uh, of Weaver, or from Cacti, that is whatever part of the Cacti system is trying to tell the application, you need to log this asset now. All it can do is provide the right instructions in the right way. It's ultimately, it has to trust that the application is locking the asset in the way that the application only knows how. So this is what we are. This is how the applications, the samples are currently written. So in the sample, we're just showing how, we're telling somebody who wants to build something more complex how they would do it, and in their application, whenever they are trying to lock an asset, they might be doing something more complex. They might actually want to do something more with the asset that currently we are not doing in the simple asset chain code. In the simple asset chain code, we are just doing the most basic operations of the asset. We just have an asset is just a data structure with some fields, and then we are just creating a flag saying lock, right? That, if you look at the chain code, that's basically all it does. Now, in a more complex business workflow, they might want to do something more with the asset when they are locking the asset. So that's the yeah. I mean, and that's these samples are meant to serve purely as samples, and they're meant to show you how the applications can receive the right instructions, and then how they lock is really up to them. Does that make sense?
So, but I'm a little puzzled because earlier you said that we should actually call this lock asset. So I was actually okay with just maintaining a data structure in a common data structure that identifies that something is pledged, and then leaving it up to the application to figure out how that's actually going to be implemented.
Yeah.
So when you say name this lock asset, do you mean implement lock asset the different DLTs, or do you mean maintain a data structure that indicates that the asset is locked? That's which is why I kind of like the word pledge, because it's something that the DLT isn't already doing, and so it's saying that, okay, this is something slightly different that matches up with the claim.
Well, we have both a. It depends on what you're doing the pledge for. If it's in the context of the asset transfer, then it's doing something different from the lock asset that we're doing for an exchange. So in both cases, we are maintaining common data structures. I think for a pledge, in the case of pledge, you're maintaining a pledge structure. In the case of an HDLC asset exchange, you're maintaining a lock structure along with a unique contract ID that indicates that tells you how to reference how to refer to a particular instance of an exchange, right? So look, I'm okay if you want to call this a pledge asset and then limit it to asset transfers. Then you should obviously the COPM should have a separate function called lock asset.
Yeah, sure.
Okay, why don't we just do that? I think this is probably maybe the simplest way to do it is let's just implement the functions that we currently support, and later on, if we want to merge those functions, uh, we can do that. But right now, the priority is to create this common module and common interface.
Okay.
There's also one more thing that you had. If you go further down, I wasn't sure what it meant. Just a little further. A little further. State. Yeah, we discussed proof state, but there was something below this, I think, in the definitions. Transferable asset. Yeah, what is an asset account?
So this is the wallet.
Okay.
What resolves to a user ID. This is the important part. So this user on this network with this gateway. With the idea that when we transfer something, we're going from one account to another account.
Okay. Okay. Yeah, I think that might be useful. I need to. Yeah, sure. Do you have where is it getting used? Is it in the asset pledge? Right,
Yes.
asset
So
account.
so
You
in
have
the
got it.
in the
Got it.
pledge.
Okay. Okay. Yeah. So it's a structure that that abstracts away the sender and the recipient, right? Okay.
Yeah,
Okay.
that's right.
Yeah, that makes sense to me.
Okay.
Okay, thanks. Yeah, sorry for monopolizing the time, but I guess I don't think anybody else had any items on the agenda, right? Peter, Mikhail.
I did not.
No, nothing from me, thanks.
Okay.
Okay.
Yeah, I think it's a good start, Jennifer. So looks good. Yeah, once start. Oh yeah, one thing we were discussing the uh, relationship between the Cactus connector for Fabric and the Weaver driver for Fabric, right?
Yeah.
So
I just wanted to use the code that was there. So, and I wondered if, because we needed, I was at the point where I wanted to start testing with a
Mhm.
fabric network, and it needed the chain code deployed, and so I wondered if I should use the connector code in my initialization process. But thank you for the information that's not to be used in a production system. So maybe what I'll do is just go, not worry about that part, and make sure that the chain code is deployed separately.
Yeah, you can if you want. I have to go back and look at that the PR to package the fabric driver, right? As a connector. Is it as a connector plugin? I think it was done, right? The one where in the plugins folder we have a Cactus
Yeah,
Weaver driver
I think
fabric.
I
I
have.
think that
I think I've seen
is
something there. Yeah.
right.
Yeah, but
Yeah,
that was just a symlink, though.
it's just Simlink,
So
right?
yeah,
Yeah,
it's
yeah,
not implementing the interfaces yet. So in that sense, it's not yet made
right,
official that it's
right.
a plugin.
So Jennifer, if that's something, I think it would be great if and if you do this, we will consider it part of uh, your mentorship targets, and we can remove something else from it in the interest of time. But it would be, I think, useful to try and see how you unify what currently exists as the Cactus connector fabric. I think it's called Cactus connector fabric ledger, right? And there's the Cactus connector Weaver driver, Weaver fabric driver, and that's just a symlink as Peter mentioned. So, but what we would like to have ideally is to merge the two into just one plugin, which contains the code from both. So that would be good. But again, you can decide what you want to prioritize. You can. I know you've been working on the COPM and the API for now. So if you want to just defer that for now, we can think about it later.
Okay. Yeah, my preference would be to, like, I'll need to obviously be aware of all the content in the Weaver driver, but my preference would be to just keep going on keep plugging away on the COPM for now, because
Yeah.
I've only looked at Fabric so far. Like, there's everything else is a mystery.
No, sounds good. Yeah, and as always, message on the channel, and sorry, I have several channels that I have to focus my attention on, but whenever I see a message, I'll respond to you.
Okay.
Okay, I think we are done for the day, then. Peter.
Yeah, nothing from me. Good discussion, everybody, and thanks for joining.
Thank you.
Bye, guys.
See you next week.
See ya.
Bye.
Thanks, bye.